students, so our question says a model for quantized motion of an electron in a uniform magnetic field V states that the flux passing through the orbit of the electron is nh by E, where n is an integer, h is Planck's constant, and E is the magnitude of electron charge. According to the model, the magnetic moment of an electron in its lowest energy state will be. So in order to find this question, we are first given the flux. So flux is easily found by integral v dot ds equal to nh by E. And we know that when we are integrating it, we will get B into area equal to nh by E. Now this is the equation, and we're going to derive for area from here. Area equal to nh by EB. So this is our first equation. Okay. So in order to find the magnetic moment, so we are asked to find the magnetic moment. Magnetic moment is given by I into area. We know the area and we will have to find the current. So we know that current equal to Q by T. Here Q is for an electron, it will be E by T. So we will be doing time, we can find it as time equal to distance by velocity. And distance, since it is revolving around an electron, we have 2 pi r. 2 pi r will be the total distance, total circumference of the orbit, and by v, velocity. So we are going to substitute here E by 2 pi r by v. And in order to find r, we will be trying to find r, and so we know mv square by r. So the electron is actually moving in an orbit, just like there is a positive charge here and there is an electron here. So the electron is actually moving here, and it will have a centrifugal force here given as mv square by r. And this mv square by r will be equal to the magnetic force. It will be equal to the magnetic force. Magnetic force. So it will be the force will be equal to the force due to the magnetic field. And in order to find it, we know the force due to the magnetic field is QVB. So we'll be cancelling out V, and we'll be getting R equal to mV by QV. Okay. And we will be substituting this value for R here, and we'll be getting I equal to EV by 2 pi into mV by QB. And we'll be cancelling V here. We'll be getting QB by 2 pi for I. So we have found the value for I here, QB by 2 pi. Next, we'll have to find the magnetic moment. We know the area and we know the current, and we'll be substituting it here. Magnetic moment will be given by IA equal to QB by 2 pi m into area. Area is NH by EB. Okay, so Q, instead of Q, we will be putting here E here, and B we will be cancelling it, and here also we will be cancelling, and made a mistake somewhere. So here we have to put Q here, so it will be Q square, right? Q square, and here also it should be E square inside. So we'll be taking, and we'll be getting one E extra here, and NH by 2 pi m. All right. So here n will be equal to 1 for the first orbit, for the ground state, and we will be finally getting magnetic moment equal to EH by 2 pi m. Okay.